Now, if you have a reaction H2 gas plus what N2 gas give what NH3 gas, right? So we have to balance it. But then I should what use to what to this calculation here. If this is the first video you are seeing here, this is a video on what chemical what equilibrium, and this is going to be the first video on what chemical equilibrium. If you have not watched the first video on chemical equilibrium, where I explain how to write equilibrium constant expression and the various calculation under equilibrium constant expression, then I will leave the link at the description below. But in this video here, I'm really going to dive deep into some questions I want to see in the exam. So, if for example here we have this reaction, the Kc of this reaction is what 1.8 exponential minus 3. It's okay. Now, there are various ways you can rewrite this reaction here. You get that this reaction is what balance. You get there are various ways you can what rewrite the equation here. So, if for example here we have a second reaction, NH3 gas. Here we have what 3H2 gas plus what N2 gas. And you're being asked to calculate what the Kc for this reaction. You get. So what will be the Kc of this reaction here? Now, these two reactions are the same reaction, but just that they are related, but just that a little what changes have what I've made. What do I mean here? In the first reaction here, now H2 and N2 are what are on the reactant side, but in this given equation here, we are looking for what for the Kc is on the what product side. So how do you get the Kc of this guy here? That is related to this one here. So you can see that this reaction is a reverse of this guy here. You get now because this reaction is a reverse of this one here. What you want to do here to calculate the Kc for this particular reaction in relation to this guy here, you now to be the Kc is a what reverse of this guy. So here we have so now let us use it as what as K1. Do that. What became one here? So because this one is a what is a reverse of this one here, by K1 you're going to be what Kc raised to what minus 1. You get so then to get the k of this value here, that is going to be this guy, the inverse of what of this one here. You get so here we're now going to be K1 equals to here we have 1.8 exponential what minus what 3. So what you want to do so is use your calculator to punch it. Now this are also sent as what 1 over what 1.8 exponential what minus what 3. You get so 555.5. You get that is the Kc of this guy in relation to this one here is going to be 555.5. You get so now let's look at another one. So now look at a second what reaction here. Now because are two of them are also what related here. Now this is what is the main reaction here. This is what the given reaction here. We are looking for the Kc of this one here related to this one here. So if you should, how do we get the Kc? We just say K2 because I've done K1 previously. So this K here, how do we get this one here? Therefore, you have to look for the relationship. You get first you want to do here the reactions they have now the reactants are the same, the product are the same. So this reaction is not what is not a reverse what reaction. You get that? So it means that this K2 you're going to be what equals to Kc. You get but what you want to look at is that the main reason why this K2 equals to Kc here because it is not what reverse or like that first one we did. You get now, but we find clearly that the mole fractions are not the same. Like the mole are not the same. Yes, 3, yes, not 3 over 2, yes, not 1, yes, not half, yes, 2, yes, not 1. So it means that this reaction is gotten by multiplying this guy by what half. You get if you look share the difference between this one here, difference what is half. You get, because half times three, here this is what you are going to get here. Then half times one, this is what you got here. Half times two, this is what you got here. In the sense that this guy is different from this guy here due to what half. So to get the Kc for this second reaction, going to be Kc raised by what half. Do that. That is for you to get this one here, the case of this one here, that is they're going to be the case of this one raised to what half, because the difference is what is half. So before you can solve any question, you can tell for what look for what the difference you get. So if that is the case here, you have now I have also the same time what square root of what kc. So my k2 you go to do what you just going to input your value here. You have one square root of what 1.8 exponential what minus 3 0.0424. There is what answer here. So you can see that when the question is being given to you like it's fair for you have to what note that what difference what separates guy from this guy you get. So that is first you want to do. Then now the moles that changes here you need to what raise to what the power. Now let's try on that one. So now look at what this third reaction here. So that it's still the same reaction here, but a little what changes here. So they're asking about on the K for this particular reaction in respect to this other one here. So the first thing we want to do is to what check if that is same. Find out here the reactant side here and now what on the product side here. Here the reactant side here and now on the product side here. If not, this reaction is reversed in respect to this guy. You get, so that my K3, remember when a reaction is reversed, then it's going to be an inverse of what of that reaction, right? So here we're going to be 1 over what Kc, which also is things about K my Kc raised to power minus 1, right? So this is the first thing we want to do here. The next is that the moles are not the same. So what difference between two of them? You get, so let's have what NH2. NH2 here is 4. NH2 here is what is 2. It means that the difference between two of them is what is 2. But if you multiply by 2, here we have 4. Then here we have 6, here we have 3. If I should multiply by what 2, I'm going to have 6 here. That is the difference is what is 2. That is this reaction is gotten when we multiply it by what by 2. You get, so you want to know the different now what made the mode to be different you get. So once you figure it out, then what to what to raise to what to the power. So here you can say raise by what 2, or you can do it like this. You get, so you say that this first reaction is not only reversed against what other one here, but also what multiply by 2. You get, so this is really want this is one thing you really want to do here. So 1 over what 1.8 exponential what minus 3 all raised power what. Here we have 308,641.97. Now we can convert it to what to a standard form, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you have 3.08464 exponential 5. So this is what that's here. So now let's look at some real problem. Do you get that? So now let's look at what a typical exam question. This is just the way you are going to see it in your exam. So that at 745 kV, K is 0.118 for what for the following reaction. Look at what reaction here. You get. Now they are now asking what is the equilibrium constant for each related reaction at the same temperature. Here we have the first one, here we have the second one. So yeah, we really want to calculate what the Kc for this reaction here using this particular one. You get. So let's look at what the solution here. Solution. So the relation between this one here we have the first one. 2NH3. So here we have So what difference now? When you relate this to here, what can you talk about this to? You get, because you want to calculate the case of this reaction in respect to this one here, right? So when you look at it very well, this guy is an inverse of this guy here. How do you know? How do I know that it's an inverse? Now, NH3 is on the what product side, but NH3 is on the reactant side here. You get N2 H2 is on the reactants, is on the product side here, but here is on the reactant. So that is this reaction is the inverse of this one here. You get, so it means that my Kc for this reaction here, my Kc for this reaction is going to be 1 over what the K. You get that? Because the equilibrium constant for this reaction is what is K, right? Which is what 0.118. So what I want to do here is to what impute the value. My K is already equals to 0.118. So here I have 1 over what 0.118. So what I want to do is 8.7475. So that is the answer here. So this related to here, the case for this reaction is what 8.4715. Half N2 gas plus what 3 to H2 gas. Here we have NH3 gas. So the first thing you want to do here is to what? Now when you compare some with what with this main reaction here, what is different here? Now the reaction is not reverse. The reactant side is going to be the reactant side. The product side is also going to be the product side here, right? So here we can say Kc is equal to what K. You get, because it's not being reversed. You get, now, but what happened to the move? How many more do you have here? Here we have what? Uh, Here we have what? One. How many more do you have here? Here we have two. That is, the difference is what? Difference in mole is what? Half. Right? Now, if you compare it here we have 3 over 2. Here we have what? 3. Then the difference also what? Half. Right? Then, this one here is 1. Here is what? 2. So the difference is what? Is half. That is, we got this reaction when we multiply here by what? Half. So anything multiplied to it is going to raise to what to the power. You get that? So my case for this reaction is very easy. Case C, what you want to do here is what impute your value of what? K, which is what? 0.118 all raised to the power of half. We also think as square root of what? 0.118. So what you want to do here is 0.344. So that is what the question. So now let's look at what second question. You can pause the video, then attempt the question based on what I've done in this video here. Then you should be able to what answer this second question. So go ahead, pause the video, then attempt the question. Then by the time solving, the confirm if your answer is correct or not. You get, so in case you solve it and after solving my own and you got the same answer, just reply or just comment on the comment section that you got the answer, so that I will know the people who are actually what following this content. You get, so it's very important to try this one here. You really want to know if you understand what I'm teaching or not. You get, so look at it very well. So that at 827 degrees centigrade, the equilibrium constant for the reaction, look at the reaction here, is 7.9 exponential 4. Great. So this is the case C for this reaction here. Calculate the equilibrium constant for the following reaction at the same temperature. You get, so what you want to do here, now let's write some R's. SO3 here, gas, SO2 gas. So now if you should relate this one here with this one here, what can you see? Therefore, the reaction is reverse, right? How do we know it is reverse? Now, how do we know it is reverse? It's because SO3 is what is on the reactant side, but in the main reaction is on the product side, so it is reverse. And the other this one here that is what is on the product side here. is on the right hand side here. So this guy in respect to this one here is a reverse of this one here. So you can say the KC for this relation is going to be what the reverse of this here, which is what K. K, right? So which is what K. Now the ratio is not only reverse. If you check the mole here, here we have how many? One. Here we have how many? Two. That is here we have how many? Half. Here we have how many? One. So the difference between this one here in terms of mole is what is half. Hope you understand. In terms of mole is what is half. You know that this one is being multiplied by half to get this one here. Do you get that? So what I want to do here is what check what the difference in their mode. Difference in their mode is what is half. So mean that everything is going to be what against what half. Do you get that? So what I want to do here is what impute your value of what k in the question given. So you have k c for the reaction going to be 1.7.9 exponential what 4. You get we also the same thing as the square root. You get so here go to be square root of what 1 over what 7.9 exponential 1 exponential what 4. So you calculate the answer is going to be 3.5. So the answer is going to be 3.56 exponential minus 3. So now let's look at what the second one. So what I want to do here is to what copy it out, right? So here I have 2 over 3 SO2 gas plus 1 over 3 O2 gas. You have 2 over 3 SO3 gas here, right? So let's compare this one here with what main equation. Now what can you say here? The reaction is not reverse. Now the product, the reactant here also the same reactant here. Put it here, put here, right? So it is not what reverse. So here you can say Kc equals to what K because it's not reverse, right? But now let's check the difference in their what in their mole. Here, what do we have? Here we have 2. Here we have 2 over 3. So you can say the difference is what 1 over what 3. You get because if you multiply it by 1 over 3, what are going to get, right? Now here we don't have anyone. Here we have 1. Here we have 1 over 3, which is also the difference here, right? Then the same to the other one here. So the difference in their mole is what 1 over 3. So what we want to do here is to say 1 over what 3 here. Yet, so this is what you want to do here. So the method is next to what substitute your value. So Kc equals to 7.9 exponential what 4 raised to what 1 over what 3. So this also be sent out as the cube root. You get the cube root of what of this one here. So your calculator is going to help you to what get the answer. So Kc 42.91. That is what answer. So you can see how easy it is to what use the equilibrium constant here to get the equilibrium constant what of various reaction related to what to a particular what reaction. The next one to look at is what other confusing aspects that you see in the exam. You get so when two reactions they give to you and they ask to what get the equilibrium constant for what for a major what reaction. That is next you are going to look at. So now let's look at this problem here. This problem is a typical exam question, so you really want to pay close attention to this question. You get because these are questions you should work from you should master because you want to see them in the exam. Now it's just like the one we have done, but it's a little bit what complex here. Now determine the equilibrium constant for the following reaction. Look at the following reaction here. Say from the following data, now then you are combining these two reactions here to get this one. You get so these two reactions, you want to combine these two reactions here to get the Kc of this one here. Now each of the given equation here have their own different Kc value. You get so how do we combine these two here to get this one here? It's very easy. So if you look at the first one here, what we want to do here is to check what is coming with the two of them, right? Here we have O2, here we have O2, right? O2 are they the same thing here? Now because now what is here also the same thing what is here on the same side. It means that you are not going to alter what this reaction here. Then the reason why because oxygen gas is here, is on what reactant side. Oxygen gas is on the reactant side. Not only that, yes, here is half, here is half. You get now because two of them are the same. You are not going to what alter this what reaction. So you are going to what leave it the way it is. You get so if you write it like that, here are N2 gas plus what half to O2 gas. Right? Then you have N2O gas. So remember we did alternating, so the K will go to be set K equals to 3.4 exponential what minus 18. You get now. So we are done with the first one here. Now let's look at the second one here. So what is common between two of these? What SO2, SO2, SO3, SO3. So now SO2 is on the right hand side here. Is on the right hand side here. SO3 is on the product side here. Is on the product side here. So we are literally doing no adjustments or adjusting what this reaction here because they are the same. So I want to leave it like that. So you have SO2 gas plus what N2 gas. You have N2 gas plus XO3 what gas. Get right? So my K2 equals to 16.5 exponential what 18. So what happened here? So we have to cancel out some things out. Now those things that are common between two of them, we have to cancel them out. Firstly, nitrogen gas is on the what reactant side. The first one here. The nitrogen gas one is on the what product side here. There are different what reactions. So when you have two things on different side of a reaction, reactant and product and reactant, what they will do, they will cancel out, right? And they have the same rule. So this will cancel out this guy here, right? Now the main reason why it's cancel out one here because here is what is on the product side. So here is on the reactant side, here is on the product side. So you cancel out one will cancel out, right? Next one to do here, the same thing with this one too. This guy go out with this one here. So now what is the last one here? So when we combine them together, we have to get a final reaction. Now what is final reaction? Here we have SO2 gas plus we have half O2 gas. You have what SO3 what gas. So how do I get my case? Like I said, this one related to here. So my K is going to be what K1 times what? Sorry, K1 times what? KO2. You get. So usually I want to multiply these two things here. 56.1. So that is the answer here. So when the question is like big gift, you have to make the word appropriate adjustments. But the good thing is that there's no point of adjusting it because we compare each of them, they are already in their proper position. So you just have to combine the two of them, then strike out or cancel out those ones that are common multiple times, right? Then we get what our final answer. So our final equation must correspond to this one here. If my final equation after combining them do not correspond to this one here, then is my calculation is wrong. If they are the same, fine. The final KC is when I multiply two of them. You get it. So let's look at what down here so I understand better. So now let's look at what this question here. So it said, given the reaction, look at the two reactions here. Look at the reactions, right? Each of them have their what KC. You get it. What is the value of KC for the following reaction? So now the first thing you want to do here is to what? Make sure you check if the reaction are balanced because if the reactions are not balanced, there's no way you can you can get the final what reaction. You get. So the first thing you're going to do here is check maybe what the balance for the equation if they are balanced here. Please, when if you check it very well, they're all balanced. You get. But well, one thing I understand is all know is that they will only give what the word correct what equations. So now, how do we solve it? Now I want to adjust this reaction here. Now for the same atoms here should be the same to here. Right? So the first one to do here, you have when compare this guy and this guy, what's common between two of them? HF, hydrogen with fluoride, right? Hydrogen fluoride is on the reactant side here. Hydrogen fluoride is on the reactant side here. Fine. But the problem here is that here we have one, here we have two, right? So to make it to be the same, I want to multiply it by what? Two. You get that? So because here is two, they're on the same side, so I'll multiply it by what? By two. If I should multiply it by two, you're going to be two, two, two. Then I'm going to get a new KC. So we're going to be what? 6.8 exponential what? Minus 4, all this by what? 2. You get? So let I'm multiplying what this first question here. So you have 2HF aqueous. Then give you what? H plus. So which what? 2H plus aqueous plus 2F minus aqueous. Do that. So my KC now, my KC here going to be what? 6.8 exponential minus 4. All this for what? 2. Do you get that? So I want to get the answer. 4.624 exponential minus 7. So that is it. So that is for the first one here. You get. So now let's look at this other one. If you look at this other one here. So what's common to 12 then? Here we have 6242 minus is on the what? Product side, but yes on the right hand side. This guy is on the right hand side, but yes is on the product side here. So what to make sure to be the same with this one here? You get. To make side to be the same with this one here, I want to reverse the reaction. So if I should reverse the reaction, here I have 2H plus, right? Here I was 2H plus because I'm reversing it here. Aqueous plus what? C2O4 2 minus aqueous. Then here I have H2C2O4 aqueous. Yes. So there's I want to have what a new K for this reaction because I reverse, so it's going to be the inverse of this other one here because of the what the because of what I reverse. So here we have KC going to be 1 over what that value there. So we're going to be 3.8 exponential what minus 6. A little bit. So here we have 2, 6, 3, 1, 5, 7.8, 9, 4, 7. Reaction. So here we have 2HF aqueous. Here we have 2H plus aqueous plus 2F minus aqueous. My K C equals to what? 4.624 exponential what? 7. My KC equals what? 4.624 exponential what? 7, right? So the same thing here, I want to write as usual 2H plus C2O4 2 minus aqueous. You have H2 C2O4 equals my case here equals what? 2, 6, 3, 5, 7 dots. 5, 7 dots. 8, 9, 4, 7. So what I want to do now is to combine them. So what can we cancel out? Can only cancel out this one and this guy here, right? These are the only two things. This you can only cancel out this one here, h plus here. Here is what on the product side, here is what is on the right hand side. The same mode, so you cancel the out. So in my final reaction here, you go to what? 2HF aqueous plus what? C2O4 2 minus aqueous. Then you have H2C2O4 aqueous plus 2F minus aqueous. So what will have be what final case? Final case 0 dot 1 2 1 7. So that will be the answer. Wow. So we have come to the end of this video. Please can leave a like and a comment if this video is really helpful. I really want to hear from you. If this video is helpful, just type helpful. If you understood what I've done and you have gained a lot of value for this video, maybe you could not solve this question before, and with this video here, you'll be able to solve this question. I would likely want to hear from you in the comment section, because that is where we will communicate. You get, so we only communicate through the comment section. I read those of your comments. If you have any question, you can quickly ask your question. If you have any topic we want to do for you, you can keep it there. Do you get that? So if in case you want to contact me too, you can also contact me. Just say you want to speak with me, then I will give you a link that you can reach me directly. You get. So thanks for watching. See you in the next video.